YouTubers! Welcome to yet another episode of G-Tech. As you know, we've done a series of the repair of a phase linear 400 Series 2. In this episode, we're going to start by powering it up with an incandescent current limiter and a variac. Then we'll be setting the bias and testing it. And then ultimately, we're going to listen to it. Let's get started.
Warning. Do not attempt this project unless you are experienced with electrical circuits. Serious injury, property damage, and even death can occur with this wire.
We have the phase linear 400 Series 2 connected to the incandescent current limiter, and that current limiter is connected to a variac. Let's bring up the voltage to spec and see if we have any shorts. Here we go, 120 volts. The light bulb is barely lit, so we are good to go. Let's set the bias. I have the fluke connected to the left channel bias point and the Bryman on the right. According to the service manual, the bias should be set between 350 and 400 millivolt. So let's set it to 375. We will start with the left channel first. There we are, 375 millivolt. Now let's adjust the right channel. As per the service manual, the recommended warm-up time for the amplifier is several minutes before setting bias. We've already done that. Okay, bias is set on both channels for 375 millivolt. Now let's test the amp under load. I connected a signal generator, oscilloscope, and two 1000 watt 8 ohm dummy loads, one for each channel, to the amplifier for testing. I set the frequency for 1 kHz, and let's bring up the volume level on the left channel. Now let's bring up the right channel. Setting both channels even at clipping, we have 44.69 volt RMS. Doing the math, that gives us 250 watts RMS a channel, both channels driven at clipping into 8 ohms. Not bad. The rated power is 210 watts RMS a channel. So why do we have 40 watts a channel more than spec? If you take a look at the schematic, they show the line voltage at 117 volts AC. Power companies today run higher line voltage than that. My line voltage varies between 123 to 124 volts. Take a look at the line voltage of 117 volt going into that amplifier. Now look at the rail voltage. It is plus minus 81 volts for a total of 162 volts. Now let's raise the line voltage to 123 volts, the voltage coming out of my AC outlet. If we check that rail voltage again, we have almost 86 volts for a total of 172 volt, about 10 volt higher than the schematic calls for. True, we set the rail voltage to 120 volts when we tested the amplifier, so we did not have the line and rail voltage we have here. We only had 5 volts more total on the rail. In my opinion, these amplifiers were underrated. That, in combination with a higher line voltage, in my opinion, is why we are achieving 250 watts a channel RMS. Let's listen to this amp. I will connect it as a subwoofer amplifier to my Yamaha RX A6A home theater system and use it with my JL Audio 15-inch 4-ohm subwoofers. I built a cabinet for them tuned to 28 Hz as the minus 3 dB point. As you can see, I brought up the 40 Hz test tone to 100 watts. The subwoofers are 4 ohms, so we were at 200 watts a channel. The movie I played peaked at about 100 watts a channel. Well, there you have it. We've repaired, tested, and listened to a phase linear 400 Series 2 amplifier. In the next episode, we're going to get into the upgrade of that amplifier. So stay tuned on this channel. And if you enjoy these episodes, hit the like and the subscribe button. And we'll see you on the next episode. It's a take.